Hello, so I'm going to do this page in the notes, and this is really the only page I'm going to do in the notes for the most part. This is going to cover two sample hypothesis testing for the difference between population means. I'd also like to apologize for the audio quality. Hopefully you can hear me. I'm using a microphone that is really all I could find at the moment. It's not optimal. But anyway, let's get through this. So what we're going to do is a hypothesis test for the difference between population means. So in this problem, it says, suppose you are asked to do a statistical study about the number of hours seniors and freshmen at CHS spend doing homework in a week. You collect samples from each population. Okay, so that means that they're independent samples. To find out with some degree of certainty if seniors spend a different amount of time on their homework than freshmen. So we just want to see if there's a different amount of time spent, and below is what you find out. So this is the sample data from the population of freshmen, and this is the sample data from the population of seniors. And we want to do a hypothesis test to figure out if a difference actually exists. So because it's a hypothesis test for the difference between population means, our null and our alternative hypothesis aren't going to involve proportions anymore, they're going to involve means. So we have P sub F for the mean amount of time homework spent on all freshmen, and mu sub S, which is the mean amount of time, population mean amount of time for seniors. And we just want to see if a difference exists, so we just want to see if the means are not equal to each other. And remember that you could write it like this, or you could write it something like this. And either of these ways are considered acceptable to do that. And as always, we say where mu sub F and mu sub S are the population mean times freshmen and seniors do homework. All right. So that's one point there. That is the null and alternative hypothesis. And as with every hypothesis test, we are going to do conditions. So with our conditions, because we have two samples now, we have to make sure we have random and independent samples. So we have random and independent samples. And also, the sampling distribution. Now in this case, your sampling distribution is the difference between the statistics. So the sampling distribution of x bar sub F minus x bar sub S is approximately normal, right? And because this is just for the mean, it's not a proportion, there's no n times p or anything, we just look at the sample size of the freshman is greater than or equal to 30, and the sample size of the seniors is greater than or equal to 30. And that's verified. Sometimes in this case, you may have like a dot plot that you'd have to refer to if the sample size is less than 30, or maybe the problem will just say assume approximate normality for the populations. And then you would have to say those things. But in this case, the sample size is greater than or equal to 30, so we can just move on. Okay, so that's 2 out of the 4 points. Okay, and now we have to name our tests. So this is a 2-sample t-test for mu sub F minus mu sub S. And naming the test is very important. Okay. And then we have a t statistic, because we are talking about means. So remember, when you have a t statistic, you talk about means. Remember that mean Mr. T is what we go with there. So the statistic, and I just want to briefly show you here this. So this is the purple sheet that I give you. So the standardized test statistic is the statistic minus the parameter divided by the standard deviation of the statistic. All right. So the standard deviation of the statistic is going to be this one right here, the square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. Notice that there's a special case here, and if you remember to proportions, there was a special case for proportions when P1 equals P2, and this is what you assume under the null hypothesis. So you're normally actually in the special case for the sample proportion one, difference between sample proportions. But for the difference of sample means, you normally don't assume the variances or the standard deviations of the populations are equal. Usually you're not in this case unless the problem tells you to. There's ways to determine this, but it's really beyond the scope of this class. So most of the time we'll be using this one for the difference of sample means, and then as review, we were using this one for the difference between sample proportions. So we're going to use this for our denominator when we calculate our standardized test statistic. Okay, so we're going to go back to the notes here. So we have x bar sub f minus x bar sub s minus mu sub f minus mu sub s, and then we have the standard deviation of x bar sub f minus x bar sub s, which is the standard deviation from our purple sheet. And we'll use that formula in the denominator. So x bar sub f is, if we go back up here, is 4. X bar sub s is 5. So this is going to be 4 minus 5 minus mu sub f minus mu sub s. Well, remember that comes from our null hypothesis. And in our null hypothesis, we are assuming that that difference is 0, that there is no difference in the null hypothesis. So this is just 0 over the square root of, okay, and then this comes from our standard deviation. So our standard deviation for freshmen is 1. Our standard deviation for seniors is 0.5. So this is 1 squared, because it's the variance, over plus 0.5 squared over, and then our sample sizes are 50 and 60 respectively. So 50 and 60. Okay, so we'll put this in our calculator and see what we get here. So, and I would advise you also practice putting this in your calculator as well. That way you kind of know that you're doing it correctly. And it's just good practice for you. Okay, and when I put this in the calculator, I get negative 6.433. So verify that you got the same thing. Now remember, this is a 2-sample t-test. So, we just want to see if there's evidence to support that a difference exists. So if this is negative 6.433 and this is positive 6.433, our p-value is going to be the sum of these two tails because it's a two-tailed test. So we're going to go to find this area, we would go to, on our calculator menu, and I wouldn't write this down on an actual AP exam, I'm just telling you how to type this in your calculator. So we're going to go to menu, and then we're going to go to option 5, probability, and then we're going to go to the next option 5, distributions, and then we're going to go to the next option 5, so 555, it's like a phone number that doesn't exist, and TCDF is what we want. Now we want our lower bound, and our upper bound is negative 6.433. Now remember with a t-score, we are asked for degrees of freedom. And your degrees of freedom is usually the sample size minus 1. But in this case, we actually don't have a sample size, or we have 2 sample sizes. So which sample size do we use? And there's a couple things that you might think of doing here, and there's actually a really complicated formula for an exact degrees of freedom. Later we'll do this in the calculator and we'll see the exact degrees of freedom. But if you're doing this manually by hand, the more conservative approach, which will maximize the p-value, is taking the smallest degrees of freedom minus 1. So that's 50 minus 1, which is 49. So we're going to use 49 degrees of freedom. Most of the time you'll do this calculation with the calculator anyway. And by calculator, I mean you'll use the actual statistical test in the calculator, and we'll do that in a little bit here. Okay, so I end up getting a p-value of, my p-value equals 5.02 times 10 to the negative 8th. And remember, that's after multiplying by 2 because it's a two-tailed test. So when you do this in the calculator with 49 degrees of freedom, 555, you only found this area. You need to multiply by 2. So that p-value is after multiplying by 2. So then our last point is going to be a conclusion. So that is obviously a very, very small p-value. So we're going to say there is sufficient evidence. And if we go back to the problem, it just says let's do a hypothesis test to figure out if the time freshmen and seniors spend on homework is different. So we're going to say there's sufficient evidence to support the claim that the mean time seniors and freshmen spend on homework is different. And remember, there's sufficient evidence because our p-value is very small, so we always have to link that back to an alpha level. So p-value equals, we'll restate that, times 10 to the negative 8th, and that is less than alpha, which we'll just say was 0.05. But obviously that could be rejected at like a 0.00001 because it's just such a small p-value. We'll restate our test statistic. And because it's a t-distribution, we'll also list our degrees of freedom because depending, if your t-statistic is this, your p-value is going to change based on the degrees of freedom. So it's important to also list how many degrees of freedom you used. Okay, so that is basically a summary of the test. Okay, now, as I've said in the past, when we do these two sample tests and we did a proportion, we did it on the calculator. So let's do it on the calculator now. So take your TI Nspire, and what I want you to do is I want you to do menu. So go to menu, and we're now going to go to statistics, which is 6, option 6. Then we'll go to stat tests, which is 7. And we want a two-sample t-test, which is option 4. Okay. Now, a screen will come up and it'll ask for data or stats. It says data input method. You want to make sure that you choose stats from the menu. Okay, so make sure you choose stats. Sometimes you'll be given actual data and you'll have to do that. And then it asks for a bunch of information, so from the statistics that you have. So I'm going to scroll up here and show you back to this one. So the X bar sub 1 is 4, that's for freshmen. Standard deviation is 1, sample size is 50, population of seniors is 5, standard deviation is 0.5, sample size is 60. The alternative hypothesis is two-tailed. Okay, and then it asks for this thing. It asks for this thing called pooled. Okay, and pooled is almost always going to be no. That goes back, if we go to the back to the reference sheet, that goes back to You're pooling when you're saying that they're the same standard deviation. You're pooling all your data together in one standard deviation. And most of the time, as I've said, you're not going to assume this unless the problem states otherwise. Most of the time, you are going to assume the standard deviations are not equal to each other. So most of the time, the pool will be no. Okay. So I'll say not pooled here. All right. And I'll scroll back down. So there's a lot of things this gives you, but things I want you to look at is the t-statistic is the same. Okay. The p-value, though, is different. The p-value is 1.39. Still very small, but a little bit different because the degrees of freedom are different. So the degrees of freedom it gives you is 69.0542 is what you should get in your calculator. And you might say, well, this is weird. You know, it's not even a whole number, right? Degrees of freedom I thought was a sample size minus 1. And yes, it is, but because you're dealing with two sample t-tests, and you could actually look it up, there's a very complicated formula that that is used to calculate an exact degrees of freedom. And this is not on your formula sheet. This is a lot to remember. What they really expect you to do is almost pretty much use your TI Nspire. So if this was an actual AP problem, I would say go back and I would say, you know, you're still going to do in red the hypotheses, you're still going to do the conditions, but especially when you get to this green part, all this computation stuff we did, you still have to write the name on the test, name of the test, and that's why the name of the test is so important, and knowing the name of the test is so important. I would just put all the information in the calculator. I would write down the t-score. I would write down the degrees of freedom that it gives me, which remember was the 69.0542, and I would write down the p-value. Basically all this. After the name of the test, I would write down all this, and that's totally okay. You don't have to show the work for all this because you're putting it in the calculator anyway. So that is how, that's how you do the t-test using the calculator, and then we have our conclusion stated. Okay, this should give you enough information to start the Math Excel assignment over difference between population means. And then next class we're going to go over the following problems. So I want you to try this next problem on your own, and we'll go over it next class. It's over a consumer education organization, this problem right here. And also, remember to use your TI Nspire and do the confidence interval part 2. So construct the confidence interval for the difference between the population means. This is also in your calculator as well. So you would use, for this, you would use menu 6, and then 6 for confidence intervals, and then it's a 2 sample t interval, so that would be option 4. And you're basically putting in the same information. All right, that's all I have for you. Thank you.